Hi, this is James Glass with James Glass Company, and this short video is about welding and the prep work that goes into welding. This particular project is a bicycle rack for Ride Solutions, and Ride Solutions, which you can find out more about, a fantastic organization at ridesolutions.org. Ride Solution commissioned 15 of these bicycle racks to be placed around the Roanoke and New River valleys in front of businesses. You can find out how to get your own rack at Ride Solutions. The executive director over there is Jeremy Holmes. But in this video, I'm going to use this particular project to demonstrate how to prep and weld. Now, it's pretty straightforward. This is steel that's weldable. It's a low carbon steel. This is a Schedule 40 1.25" diameter product. This is a weldable angle iron, as you can see, and this is just another lower carbon steel. And there's an example of a weld right there. That weld has not had the slag knocked off of it yet. It'll be prepped prior to painting. But the important thing to getting a very good weld is prepping the steel. And as you can see here, here's this browner, kind of oilier area is the steel that's been in storage, and it's got a little bit of mild corrosion on it and some dirt and debris. And here you can see it's been ground down so that the steel itself is exposed. It's extremely important to grind the joints prior to welding. Brazing is a completely different process. There'll be a separate video on brazing, but yeah, that's it right there. And then, of course, this was aligned. I bent the rack, the Schedule 40, with my tubing bender, and then obviously custom cut everything down and custom cut the feet and things like that. But outside of the fabrication, the actual welding process involves the grinding and the welding. And for this particular job, this Lincoln welder is perfect. It's a nice small portable unit. I use it on and off the job site. It's a wire feed welder. For thicker steel like this is all 3/16 for the most part steel. I'm using a solid core wire, and what that means is this is a roll of wire. You can see it inside there, and it's fed through. There's a motor that runs through. There's a transformer inside that completes the circuit. This takes AC power, 240 volts, and converts it to DC power for welding. And the act of welding is simply, you can see the wire comes out the end of the tip here, right there. And here's a grounding clamp. And so when the grounding clamp is placed on the prepped metal, like so, and the welder is off, so we won't be doing any welding, but then this is obviously a welded joint. You can see it here. And then when I hit the trigger and feed the wire, it completes the circuit, and the intensity, the substantial resistance, melts the wire and the metal and fuses everything together. And there's another example of a welded joint. And here's another example of a welded joint. And so this is a fantastic little welder for stuff like this. I can also, this for lighter gauge metal, I use inert gas. You can't weld in the Earth's atmosphere, and so this particular wire that's used without the gas is called flux core wire, and it has a product in it that causes a gas to form around the point of the weld. And for thinner metal, it's actually nicer to use a thinner gauge, lower setting on the welder. And I use this. You can see this tank here. There's this regulator. And for that, it's just simply straight steel. And finally, safety is extremely important. I've got big, heavy leather gloves, and on top of my head, I have this very fancy welding helmet. And this particular helmet is it's an auto darkening helmet. I don't have to flip the visor up and down. There's a sensor in here that's powered by solar energy, and the shield inside the mask automatically goes dark. for welding settings, a number 10 setting is appropriate for what I'm doing, although this is adjustable from 9 to 13. That's a very brief overview on welding. And I do all kinds of welding here. Custom fences, these custom racks, custom kitchen fixtures, custom bathroom fixtures, custom furniture. So a lot of the things I design and build require fabrication and welding and or brazing and all kinds of stuff. So a lot of the concrete work I do also requires engineered support brackets, and if it's anything substantial, I farm out the actual engineering to a licensed PE, and then I build the brackets based on their designs. But for smaller brackets, a lot of home kitchens and stuff, I'll design my own brackets. And yeah, so that's it. That's the process of welding. And thank you for watching this video. Check out my YouTube channel for all kinds of other videos and all the stuff that I do.